Greetings, beautiful people. Welcome back to FindXYZ. If you have ever felt like logarithms were designed by aliens to confuse you, hit the like button, subscribe, and share this video to all your friends. Because today we are going to make this concept so simple you would wonder why it was ever difficult. Remember, think, find, and shine. Let's start thinking. And let's focus on exponent. Given 2 to exponent 3, it is obviously 8. But what is 2 to a certain exponent? That will give us 8. Your answer will obviously be a certain number. Keep that in your mind. But we can also write this in another way. So we can say log base 2, 8. Then I'll ask you, 2 to what exponent? Will give us 8. So this 2 is known as the base, this 8 is known as the argument. So my question is 2, that is the base, to what exponent will give us the argument? 2 to what exponent will give us the argument? So basically, logarithm is always the exponent. It's just a fancy way of saying an exponent. We could have just said 3, but we've just written it as log base 2 of 8 is 3. Basically, that is logarithm. So if I have a to the power of x, that will give us y. This is exponential form. Exponent. In logarithm form, we can write it as log base. What is the base? A of y will give us, the answer is always exponent, so will give us x. So this is in log form. So if I want the exponent, I can write it in log form as log base a of y will give us x. Example is given 7 to the power of 2, which is 49, can be written as log base 7 of 49, because we are knowing that the answer is always the exponent. So if I ask you 7 to what exponent will give us 49, your answer will be 2. Or 5 squared will give us 25. We can express this in log form as log base 5 of 25. The question is 5 to what exponent? So we realize that we are always looking for the exponent in logarithm. So 5 to what exponent will give us 25? Our answer will obviously be 2. Let's move on to the next section. Alright, now let's talk about some rules in logarithm. The first rule that we are going to talk about is called the product rule. What does it say? With the product rule, log turns multiplication into addition. So multiplication will turn into addition. Given log base a of, let's say, p q, you realize that p is multiplying q. We are saying that log can turn multiplication into what? Addition. So this can be expressed as log base a of p plus log base a of q. Remember, the base must be the same because this is a, the base a. Then we express multiplication as what? Addition. Now let's prove this. How does this work? Log base a of p will give us x, and then log base a of q will give us y. Now let's write this in exponential form. The base will carry the exponent, so a exponent x will give us p, and then on this side we'll have a exponent y will give us q. Then what do? Because you are multiplying, let's multiply these two equations. So I can say a to the power of x dot a to the power of y will give us p dot q. Now with indices, when the bases are the same and they are multiplying, we can add the powers. So we can write it as a and then x plus y is equal to pq. Now let's convert this to the logarithmic form. This becomes the base, so I have log base a. This becomes the argument pq, but you realize that the exponent is always the answer to the logarithm. And what is the exponent? X plus y. But let's look here. What is x? So we know x is log base a of p, then plus, what is y? Log base a of q. So we realize that log base a of p and q has been expressed as log base a of p plus log base a of q. So this is called the product rule, which turns multiplication into addition. So for example, given log base 5 of 25, which you obviously know that 5 to what exponent will give us 25, which will be 2, right? But we can express 25 as a product of two terms. So we can write this as log base 5 of 5 times 5. Now let's apply the product rule. We are saying that anytime we have multiplication, we can change it to addition. So we can express this as log base 5 of 5 plus log base 5 of 5. 5 to what exponent will give us 5, which is 1, plus 5 to what exponent will give us 5, which is 1. So 1 plus 1 will give us 2, which is the same as whatever we have here. Let's move on to the next thing. The next rule we have is called the quotient rule. What does this do? With the quotient rule, it will turn division into subtraction. Given log base a of p divided by q, division, we can express it as log base a of p. Now division is going to be turned into minus subtraction, that is log base a of q. Let's prove this. Let's represent this part of the equation with a variable, so we can say x is equal to log base a of p, and then we represent this part of the equation with another variable, so y is equal to log base a of q. Let's change this to a log form, so we can write this as a exponent x is equal to p. Then this will also be a exponent y is equal to q. Since they are dividing, let's divide these two equations. So I can say a to the power of x over a to the power of y will give us p over q. Then if the bases are the same and they are dividing in indices, what do? We subtract the power. So we can write a x minus y is equal to p over q. Then let's change this into the log form. So this becomes the base, so we take log base a of p over q. The power or the exponent always becomes the answer, which is x minus y. Take note of that. So logarithm, the exponent is always the answer. Now what is the value of x? It has already been defined as log base a of p, so let's substitute that. So we have log base a of p minus what is the value of y, which is log base a of q. So you can clearly see log base a of p divided by q has been expressed as log base a of p minus log base a of q. So we have successfully changed division into subtraction. Let's take an example. Given log base 2 of 8, so with logarithm you always ask the question 2 to what exponent will give you, because with logarithm the answer will always be exponent. So 2 to what exponent will give you the argument, which is obviously 3, right? We know the answer already. But let's use the product rule. Let's use the quotient rule. Let's express the argument 8 as a division of two numbers. So we can express 8 as log base 2 of 16 divided by 2. 16 divided by 2 is the same as 8. Nothing has changed. Now let's apply the quotient rule. With the quotient rule, we are saying that division will now change into subtraction. So we have log base 2 of 16 minus log base 2 of 2. Now 2 to what exponent will give us 16, which is 4. 2 to what exponent will give us 2, which is 1. And now what is 4 minus 1, which is 3. So you realize that when you apply the quotient rule, it works. It works. Whenever you have division, you can change into subtraction. On to the next one. The next rule we have is the power rule. Giving log base a of p to the exponent m can be expressed as m multiplying log base a of p. Let's prove this. So let's represent x with a log, which is log base a of p. Let's change this into indices. Let's change this into exponential form. So this, as usual, we'll go and carry that. So we have a to the exponent x will give us p. The exponent, let's take the exponent of to the exponent m on both sides. So this will have a to the xm. A to the xm equal to p to the exponent m. Then let's change this back into logarithmic form. So what is the base? So we can say log base a of pm is equal to, what is the, so we have mx, but what is the value of x? It has already been defined. So we have this as m multiplying log base a of p. So what does it tell us? It tells us that whenever we have an exponent, we can bring it in front of the log. Whenever we have an exponent, we can bring the exponent in front of the log. So for example, given log base 5 of 25, 25 is a squared number, so we can write it as log base 5 of 5 to the exponent 2, and using the power rule, we can bring this exponent in front of the log, and we have 2 log 5 5. Now what is 2 log 5 5? 5 to what exponent will give us the argument, which is 5, that is 1. So 2 multiplying 1, that will give us 2. So this is how you can apply the power rule. Now let's look at some generalizations. Now we are saying that log 5 5, log 10 10, log 7 7, 5 to what exponent will give us the argument, which is 5, that is 1. 10 to what exponent, which will give us 10, which is 1. 7 to what exponent will give us 7, which is 1. So what does it tell you? We can generalize that anytime the base is the same as the argument, the result will be 1. So for example, let's generalize it. So given log a, we always get 1. So when the base is the same as the argument, we are always going to get 1. Log 10 of 1, log 20 of 1, log 50 of 1, log 100 of 1. The question again, log base 10 of 1. The question will be 10 to what exponent? You realize that exponent is always key in logarithm. 10 to what exponent will give us 1? If your answer is 0, you are correct, because 10 exponent 0 will give us 1. 20 to what exponent will give us 1? 0. 50 to what exponent will give us 1? 0. 100 to what exponent will give us 1? 0. So what can we generalize? You can generalize that regardless of the base, once the argument is 1, we are always going to get 0. So we can generalize that log base a of 1 will always give us 0. So whenever the argument is 1, we are going to always arrive at 0. We are always going to arrive at 0. Then one thing is that anytime you have log base a of a to the exponent x, you are going to get x, because the base is the same as the argument, and using the power rule, we will get x. Additionally, if I have b to the exponent of log base b of x, I am going to get x because they are inverse operations, and then you have x. Take note of this. Let's do the last part of this section, which is change of base. How does this work? So given log base a of b, we can write this as log b over log a. Then we'll choose our preferred base. So let's assume we want c, so this will be c and this will be c. So we realize that we have been able to change the base of a to the base of c. How does this work? So for example, given log base 4 of 16, I can write this as log 16 over log 4, and I'll pick any base. So let's say I want to pick base 2, the same thing. So I've changed it from base 4 to base 2. Now the question is 2 to what exponent will give us 16? 2 to what exponent will give us 16? Obviously 4. Then at the denominator, 2 to what exponent will give us 4? That is 2. And what is 4 divided by 2? Which is 2. Now look at this. 4 to what exponent will give us 16? That is obviously 2. Thank you for joining me. If you find this helpful, please leave a comment. If you want me to do questions and answers on logarithm questions, comment that in the comment section. Share this to all your friends. And remember, think, find, and shine. I'm out.